Now, for this data set, there are 20 observations, so I can. Well, I tell you what. Let's just stick with the plan. Look at the correlation between x and y, 0.97, huge. Let's eyeball the relationship between x and y, linear pattern. I can visualize a linear model through the central focus of the points, and I don't see a lot of deviation there. And I also don't see any curvature or any reason to add a quadratic term or search for another type of model. Now, I'm just going to call this model 1 because we're going to look at some models. And again, our eyes are naturally drawn to the predictor. We have an estimate of 5.12, standard error 0.20, statistical significance at the 0.001 level. I'm not going to run the ANOVA, but what I am going to do is I'm going to create the residuals, the errors, for model 1. And then I'm going to look at a box plot of the residuals. And you can see we have a symmetric distribution, no outliers, so no reason to suspect a high residual. All right, so no points that appear to be a leverage concern, and certainly none that are influential. Now, let's add a point to this. So I'm going to now come in and create data 1. Well, I'm just going to call this data 2, actually. But I want to come in and load influence leverage 1, which I have on my desktop. So I need to attach it. And I'm going to actually look at the entire data set, because what I did is I just, the data set is the same as before, but I added a 21st term for comma 40. All right, same thing. Let's see what happens with the correlation. So the correlation dropped a little bit from 0.98 to 0.95, still no concern. Now I'm going to create my model. And 2, all right. So now I've attached data 2, so it's going to run the model off of. Now, what happened here is when we compare to the other model, we can see that the estimate changed a little bit. That's not a major concern for me. Well, it would be a major concern for me if the estimate changed a lot. You notice the standard error got a little larger. The test statistic is 13.9 versus 25.6, but we still have statistical significance at the 0.001 level. Now let's look at this new plot of x and y, and you can see that the point I added is right here, right? Well, because the mean of x is going to be close to the center of the distribution, I certainly don't have any issues with this being a leverage. So let's create our residuals. What did I call that? Model 2. So I'll be real creative here and call that residual 2. And I get an outlier, don't I? So of the 3, I have a high residual. Because our box plot of the residuals indicates that. I don't have a leverage issue because, again, this point is close to the mean of the x's. And I don't have an influential point because, if you look at our R squared, I have 91.0%. versus 97. Now, it did decrease a little bit, But still, 91% is still an impressive R squared, right? The standard error changed. The standard error increased here to 0.36 from 0.20. That tells you that our prediction intervals are going to just be wider, which is a little bit of a concern. But again, uh, it's not that much of a concern for me. Also, we can see that the statistical significance of the predictor didn't change. So, conclusion, the 0.440 is an outlier, but not a concern for leverage or influence. All right, let's add another data set. And let's call this data 3. This is influence 2. And you'll see what I did here is I just replaced the 4 comma 40 with 13, 15. All right, so let's eyeball it. And now you can see we have a point that is a major concern, right? It's a major concern because, first of all, it makes me believe that we're probably going to have an outlier for the residual because the line, is going to, we'll take a look at it in just a second, take the guesswork out of it. It's certainly a significant distance from the mean of the x's. And it looks like to me that without this point, I have a linear model. But with adding that point, this model, if you can watch my mouse, the slope of this model is probably going to change quite a bit. It's going to get closer to 0. So, let's let the process play out. So let's create model 3. So now we still have statistical significance, right? But notice that our estimate changed from like 5.5, right? 5.1 down to 3.3. Quite a change. Notice our standard error increased from to 0.69 from 0.20. Our test statistic is at 4.8 versus before it was 25.6. Drastic change. We still have statistical significance at the 0.001 level, but because our estimate changed so drastically, I have concerns with this being an influential point. Our multiple R squared, even piling on more evidence, is now 55.2% versus 97.3%. Major concern. And again, the standard error issue is of most concern, as is the estimate. We probably know what the residuals are going to look like. So if I do a box plot of my residual 2, I can see that I get an outlier. So this particular observation, when I add to the base data set of just the length of 20, sample size 20, this definitely checks the box of an outlier. Because of the change in the estimate and the standard error and R squared, multiple R squared, it checks the box of being an influential point. And because of our plot, get it real quickly, because this value is significant distance from our mean, we have a high leverage point too. So adding this particular point again, just diving into the weeds, getting our hands dirty, putting on our work gloves and making it happen. We'll get fancy in the next video. We can see that adding the point 13, 15 checks all the boxes. Outlier, high leverage, and influential. All right, gang, look at some pretty cool stuff in the next video, but I just wanted to, again, dive into the weeds and let you know what's really going on behind the scenes. But, and again, let me pump the brakes just a little bit. What is the problem with this approach? What's the problem with this approach? Well, someone may look at a standard error right here of 0.69 and this standard error of 0.20 and say, well, that's not a lot of difference, right? What's the line in the sand? What's the criteria for actually classifying that as the standard error increasing, quote unquote, too much, right? What's the line in the sand for our R squared at 55.2% to be different at a level of concern than 97.3%? That one may be easier to make. It's kind of like, you know, where do you draw the line of someone being tall? Well, is 6'3" tall? Is 6'9" tall? Well, I think we all agree 6'9" is probably tall. Is 6'1" tall? You know, I'm about 6 foot. And when I was in China a few years ago, sometimes I felt like a giant, you know, because, you know, I think everyone knows that my daughters are adopted from China, so we went to China 2 times, and you know, I'm not that tall, but you know, I stood out over there sometimes. I got a lot of attention. Let's put it that way. Okay, enough of that. Let's end this video. Okay, take care.